Okay, fantastic. I think we'll make a start. Well, good afternoon, everyone. Thanks for joining us today. It's a pleasure to have you all with us. My name is Greg Lewis. I'm the Head of Sales and Marketing here at EarthSense, and I'll be your host for today's webinar. Today, we're going to talk to you about indicative MCERTS and the importance of data quality in the context of construction applications and use cases. Just before we get going and I introduce the rest of the team, there are a couple of minor housekeeping points. Obviously, you'll notice as you're joining, you are all on mute. Please do keep your microphone switched off for the duration of the webinar, along with your camera, just to save on any bandwidth constraints we might have along the way. And we'll have enough time at the end for questions, so please do put your questions into the Teams chat window, and we'll do our best to get around to everybody at the end of the webinar. Those that we can't answer, we'll follow up with each of you individually via email afterwards. And there'll also be a recording of the webinar available on our YouTube channel, and we'll make sure that we email copies out to the relevant people that signed up today. So let me introduce the team. Today we've got Dave Green. He's our Senior Business Development Manager. He's got lots of experience in the construction space and monitoring in general. We've also got Richard Booth from KP Acoustics, who's the Environmental Monitoring Manager, and Emily Norman, KP Acoustics also, who works on the business development and marketing side. So without any further ado, I will hand over to Dave.
Hi, thanks for that, Greg. So yeah, I've been in the sector for about 10 years, so it's a privilege to be talking about MCERTS today in the context of Zephyr. I've been here for about 2 years, and as you'll see, it's been a project which has been ongoing for a while. So here's a quick agenda of what I'm going to talk about today. So I'll be introducing EarthSense to anyone who's not familiar with us. Similar with Zephyr, I'll give a quick run through of what the product is, what it plans to do. I'm then going to have a quick run around what MCERTS is and the purpose of indicative MCERTS, which is what we've achieved. Talk through what the process of MCERTS is and what milestones we had to go through. I'll then introduce the performance of the Zephyr and what the certificate covers before handing over to KP. So next slide, please. So anyone who's not familiar, EarthSense is an air quality company. We're a tech company, and we spun out of Leicester University in 2016. And the idea is that our products and services there help people visualize air quality on a much more granular level than ever before. We're a team of 25 strong, and we're growing. And our clients are really mixed. We have a big footprint in local authorities across the UK, with about 75 now working with. We work with regulators. We work as well with the private sector through consultants, technology providers, and integrators of our technology. And I put on there even members of the public. We've got members of the public using some of our services. We're also expanding, so we're a global company, and we've now got a footprint through partners on most continents, apart from Antarctica. Just some points down the bottom as well. Sorry, Greg, back one. I was just going to say we are ISO accredited for environmental management and quality management. We've now got certification for one of our products on MCERTS, and we've received a few awards throughout the years, and notably last year for Zephyr, we received the Innovation Award for Air Quality. Next slide, please. So the Zephyr, for us, this is a small form indicative air quality monitor. These have become far more prevalent in the past few years. In terms of what the system is there to do, is to provide additional measurements to static measurements. We use sensors which are integrated into the system. We then apply our own calibration algorithms. And the purpose of it is to provide as credible measurements as we can in a real-time, low cost and low power package. So a quick run through of some of the features. We cover a range of pollutants. So today we're talking about particulates, but we also cover a range of gas pollutants. The system itself comes with an internal battery, and that battery will sustain power for anywhere between 3 to 7 days on the instrument. And then for long-term measurements, we advise on a continuous power option, and something which we're really proud of is how flexible we are on this. So we can supply a solar panel, which with right siting will power the system year round. Where you can't get coverage of sun, you can use a mains adapter, so connect it into mains power. And then if anyone from the construction world is here, or remote monitoring, often both of those don't work. So we've recently introduced an external battery cable, which will allow you to connect the Zephyr to a leisure battery or any form of sort of 12-volt battery. And this can then sustain you anywhere in the ranges up to 3 months on a standard 120 amp hour battery. Another part of our package is how we ensure reliable data capture. So every system comes with a range of cellular communications. So we cover GSM, Wi-Fi and Bluetooth. We have a team of engineers who are continually monitoring the data. So we're raising alerts to clients where there might be issue with comms, issue with power, issue with data quality. And if there ever is a fault which we need to replace with an instrument, we ship a new instrument to be swapped out at site, all ensuring that data capture is as high as possible. And in terms of maintenance of the device, we're looking at a cartridge system. So calibrations are hosted on a cartridge replacement. This takes place at 24 months and it can be performed in field at around 15 to 20 minutes. Next slide, please. So what is MCERTS? For anyone not familiar, but I'm sure most people on this call are, it's a certification scheme which is run by Environment Agency, and it covers not only equipment, but it can also cover personnel and organisations looking at emissions of air, land and water. Today we're just talking about air. The whole purpose of it is to provide the public, I suppose, with confidence in monitoring data which is put out there, but also help end users choose monitoring equipment and services which are going to be suitable to any sort of permit requirements or legislative requirements which they have. Now, this is a big topic of debate, or is always not necessarily known. So when we're talking about air in the UK, and especially with MCERTS, there's two measuring criterias, and they all relate back to quality objectives on a document I'm sure we're well aware of, which is Directive 2008/50/EC. The separation is there's reference equivalent measurements and there's indicative measurements. So reference equivalent measurements are your standard fixed monitoring sites or continuous monitoring sites. They have their own measurement uncertainties. They have their own performance test criteria. And in the UK, the main one which we're looking at is the performance standard for continuous ambient air quality monitoring systems, or known as CAMS. So often fixed monitoring is referred to as CAMS. And there's a small nuance that there is an additional DEFRA approved particulate matter certification. And the nuance is there are some instruments which for particulate matter are certified against CAMS, but not for DEFRA. And anyone working in that space just needs to be cautious of that. When you're looking at the indicative measurement objectives, there is only one standard currently. So this is a standard which we've passed. It's known as Performance Standard for Indicative Ambient Particulate Monitors, or IAPM. There isn't currently an indicative standard for gases, but last year there is now a technical standard, which is CEN/TS 17660.1/2021. And this is now going through the formal acceptance process. So I would expect to see at the end of next year, beginning of 2024, there will then be a formal process in place, and sensors like ours can then be approved for MCERTS on gases as well. Next slide, please, Greg. So when I looked at the list of people coming today, I feel like everyone probably knows what indicative MCERTS is, but I think just a few bullet points on here. In my mind, indicative MCERTS and the equipment which is covered in it is always going to be for supplementary information. Reference equivalent measurements are there to be used to show compliance against ceiling objectives. Indicative measurements definitely aren't for that. They're there to be supplying supplementary information. So there's a few documents you probably noticed on the right hand side, and just to run through a few bullet points which I pulled out of them. Directive 2008, it says information for fixed measurements may be supplemented by modelling techniques or indicative measurements to enable point data to be interpreted in terms of geographical distribution of concentration. So there's an element here that fixed monitoring points can be supplemented by having sensors like ours to offer more granular information on a geographical distribution. Technical Guidance 22 similar in the sense that these instruments are useful for identifying short-term pollution events at construction sites and other waste sites, and are suitable for short-term or local campaigns. Again, nothing there about sealing objectives or compliance therewith. It's all supplementary information. And the last one on here is IAQM's guidance for monitoring around demolition and construction sites. And this says indicative instruments may be suitable for demonstrating that objectives are not being exceeded where measured levels are well below the criteria. And anyone working in the space, this is referencing where a site may be permitted or have part of its dust management planned breach levels for especially PM10. This is where indicative instruments can become quite useful for ensuring that those breaches are being reported to local environment health or mitigation measures are being acted upon on dust measurement plans. Next slide, please. So this is a bit of a complex slide, but it's more to just talk through the process, because I think I for one find it quite important. I think it's good to talk through what we've gone through. We worked with several partners in our application process. So working backwards, we started in September 2021. Working with NPL, which is the standard test site, we deployed 2 Zephyrs at their reference method. The reference method, which is agreed for small form sensors like ours using optical systems, is a FEDUS 200. The 2 instruments were installed. We then ran a 0 test to make sure that they're baselining correctly and there's no leakage or bad measurements at clean background levels. The test criteria is then standardly 80 days of consistent measurements. We ended up doing more measurements than that, but I'll come back to that. There is the assessment looks at daily averages. We also did look at hourly averages, but the assessment is on daily averages. And the sort of main bullet points are the 2 instruments we supplied must be precise with each other. And the uncertainty between the 2 instruments and the reference station needs to be below 50% uncertainty. There is also then data capture rates within that. The reason we ended up doing such a long test phase is because in the background, we were looking to supply supplementary data. So the Zephyr comes in several cartridge configurations, which particulates have several configurations which can be chosen along different gas measurements. And it's also all the power of flexibility options. So we were working in the background to ensure that we were reporting and covering all of those within our certification. The performance test data went to Dave Harrison at Bureau Veritas, and he's been a real pillar in here. So a big shout out to him. He's been really helpful. He compiled all the information into a standardized report, which was then submitted to CSA this year in September. CSA in the background have done a manufacturing audit of us. So that's ensuring that all of our manufacturing procedures and quality standards within the company are to a traceable standard all the way back to our suppliers. And collected with the performance test, a draft certificate was raised, issued to the steering committee, and we were finally approved last month in November. Next slide, please, Greg. So on to performance, because I still think it's quite important. We have passed for both PM10 and 2.5. I think one thing to state on here, the test is blind. From our point of view, factory calibrations, as would be from the box as shipped. This is how the test went. We deployed the instruments and then we were essentially blind to those tests. There was no additional manipulation during the test. PM 2.5 itself, it didn't make the uncertainty boundary initially. We slightly overperformed at 54%, but because the correlation and the slope was quite linear, within the process, you're allowed to apply a slope correction. Quite a few people have done this in the past. So the final test criteria, which we passed on with that slope correction, is an expanded uncertainty of 14%, slope of 0.99, and an R-squared of 0.896. And then on the right-hand side, that is the time series of the uncorrected data and correlation plot of the corrected data. Next slide, please, Greg, on to PM10. So much the same here. Only difference is the performance passed first time, or first time is in without any corrections on the data. The expanding uncertainty for PM10 was 24%, slope 1.7 or 1.8, and R squared of 0.787, and the same plots on the right-hand side. Next slide, please, Greg. And to finish a rather informative, not very exciting slide deck, here is just what certification covers. So the Zephyr is now certified for indicative particulates, the simultaneous PM2.5 and PM10 measurements. We can cover a range up to 1,000 micrograms. So working in the construction space, it means you're covered for those standard limits of 150, 200. Calibrations are supplied as supplying a new cartridge, and this is a 24-month measurement period. Within that, the way the indicative standard says is that will provide you qualitative measurements. If you wanted to do quantitative measurements, you need to do an additional calibration with a reference piece of equipment at site. But importantly, those calibrations don't need to come back to us. We just issue a new unit and it's swapped at site. And then in terms of our configurations, this covers the standard and the enhanced cartridge configurations. We do also measure CO2 and TVOCs, but those are sitting in a different cartridge, so aren't affected by the certification. And some points to raise, I think. One is we have passed without heater inlet. That will raise some questions and debate, I'm sure. We measured through September to June to July, so we did an expanded measurement period through potentially some of the more challenging times of the year. The slope correction at the current place is something which you have to apply after downloading the data. Beginning of 2021, we will automatically be applying that, and we'll be getting in touch with everyone who's got a Zephyr who is compliant to let them know what the process is for that. And really notably, we've got a big fleet in the field. Any of the old Zephyrs can be upgraded. So we're going through a process now of just confirming that. You can reach out to us, but most upgrades are a simple piece of new hardware. So of the instruments which are before the serial number, which aren't compliant, get in touch with us. We can look to upgrade. And I think that's me. So yeah, hopefully that's a good information, a dump on what MCERTS is, what we've passed, and now I'll hand over to Richard to discuss his part.
Thank you, Dave. I was very informed. Thank you. So just briefly, I'm going to talk about who KP Acoustics are, talk about using the Zephyr in the demolition and construction industry, and then have a look at some of the issues that we've had with legacy equipment and how we've overcome that. Next slide, please. So my name is Richard, and I'm the manager here at KP Monitoring, part of the KP Acoustics group. KP Monitoring is one of 4 companies in the acoustics group, and we focus primarily on monitoring noise, vibration, movement and dust within the construction and demolition industry. This often takes the form of monitoring for the environment of local receptors like hospitals, schools, and of course commercial and residential properties. For noise and vibration monitoring, we use our in-house designed and built unit called the NView, which is the only 4G enabled all-in-one noise and vibration monitor on the market. The unit is essentially plug and play and makes this kind of monitoring very simple, easy to set up and easy to operate without needing any in-depth acoustic expertise. For dust monitoring, however, KP Monitoring has historically used older style PM10 dust monitoring devices from various manufacturers. These have performed adequately but have significant intrinsic issues. Over the last 12 months or so, KP Monitoring has purchased and deployed 41 new Zephyr units across sites up and down the country, but predominantly within the Greater London area. We've made a significant shift to the Zephyr system and are proud to partner and support this system as our dust and pollutants monitor. So why have we made the change? Other units we have historically deployed tend to be large, bulky monitors, often contained within stainless steel cases, and in some cases, requiring 2 large separate enclosures to house both the sensor and the communication device. These devices also weigh around 12 kilograms, and that's before you include the weight of the enclosure, modems, and chimneys, and so on. They're difficult to lug around, and it requires no small skill to install them, particularly when you're trying to do that on your own. We also typically need to deploy these monitors at height. Specifically, the dust the device is sampling should be that which is escaping the site, not the dust that is trapped within it. We therefore usually need to employ these devices above any hoarding or dust sheet lines, meaning they can be at some heights, usually around 3 meters from ground level. The fact that the Zephyr weighs a maximum of 2 kilograms, along with its easy installation with its back bracket, means that it's an absolute breeze to install. The 2 kilograms also includes the modem for the data, the particulate cartridge, and the pollution cartridge, so everything being in the same enclosure is a great help. Similarly, the units are essentially plug and play. We can push the button on the bottom, throw it up on site, and walk away. Of course, we don't do that. We check it on the EarthSense app to make sure it all looks good first, but compared to messing around with peripherals and modems, inputting IP addresses, it's dead simple. A recent example of this is a project we have at a school in Haringey. They had some demolition works going on next door and were worried about the impact the dust may be having on the children's health. We installed a Zephyr on the site boundary above the dust screen and monitored the emissions coming into the school. While I don't advocate monitoring as a tool to hinder works, this monitoring from the school prompted the site to cease its heavy works and review its methodology. This was a win for the school, who are now much more confident in allowing their children outside to play, especially since they could check the quality of the air live before determining the risk to the children. Power consumption. A huge issue for us on site is the lack of mains power. Often we require to monitor dust levels up to 3 months in advance of any works, so no power supplies have been installed on the site. This is similar to demolition phases as well, as power runs are usually installed once the site has been knocked down and it's ready to be worked. So until now, we have been extremely reluctant to run our dust monitors using off-grid power, as the power required to run pumps, lasers, heating elements is too much to reliably run them, either on batteries or solar. One of our manufacturers did have an answer to this problem and does supply a solar solution to their system. The panels are approximately 1 meter by 2 meters. 2 of these are needed for each monitor. The controller for them weighs 5 to 10 kilograms, and the system cost is $3.5 grand, give or take, on top of the dust monitors themselves. Enormous panels and almost the price of another monitoring sensor. We also recently tried to run these legacy monitors off batteries. We were using 2 marine batteries linked together, approximately 250 amp hours each, and weighing around 65 kilograms each. These batteries still needed to be swapped every 2 to 3 days. The poor guy who had to do these swaps on site was no spring chicken, and he was glad to see the back of them. With the new Zephyr system, we've been able to confidently deploy dust monitoring devices on sites without power using very small 50-watt solar panels, only 53 centimeters by 67 centimeters. These ran pretty much flawlessly throughout last winter, with the only issue arising when our clients unintentionally cover or break the panels. This means that we now often prefer to run our dust monitors on solar panels, as the clients can't unplug them, site teams can't unplug them and put in a drill or something else instead, and it assures that our data capture rates are very high. It is usually a requirement of building and construction sites that we monitor PM10 particulate escaping from the site. However, it's often required for us to monitor PM2.5 particulate, as well as pollutants such as ozone and NOx. With historic monitoring systems, we have sometimes been able to monitor both PM10 and PM2.5, but this was only possible with one type of unit, and with others, you'd need to change the cyclone on top of the inlet to change the particulate size. This unit is used a lot in the industry at the moment, but we see that changing and changing pretty quickly now that the Zephyr is MCERTified. Furthermore, measurements of PM10 could be M certified, but not PM 2.5. Unfortunately, then, measuring pollutants required yet another sensor with another power supply and another modem. The unit you can see here was installed to monitor dust levels for a roof addition and a penthouse construction in Barnet. The requirement at this site was initially for MCERTS PM10 only, but on discussion with the local authority, they also required PM 2.5 and NO2. This meant that we would historically need to have installed 2 of the monitors you see here in the top picture, plus a 3rd monitor to capture the pollutant readings. I'm pleased to say this unit was subsequently replaced with the Zephyr capturing all of the data on its own. With data capture, using our legacy equipment, we are often dependent on the local mobile network and on the proficiency of the onboard hardware and firmware of the monitors. This, coupled with limited on-monitor memory allowance, meant that when power went offline, we would likely lose data, and that may have been crucial to the project. A loss of data could mean the difference between complaints about the site being upheld and works having to stop, and empirical evidence that particulate levels were within an acceptable limit. Now that we're using the Zephyr system, we're finding that our data capture rates are very high and typically 100%. The graphs shown here are from a monitor deployed near to West Ham's ground in Newham. This was recorded the week before last, and as you can see, even with the late autumn daylight and the torrential rain we had been having, we haven't missed a single data point. We can now show empirically that the poor performances of West Ham are not linked to the air quality around the stadium. Calibration. This isn't an issue that seems like a big deal until you're trying to run 30, 40, 50 dust monitors at once. With our legacy MCERTS PM10 equipment, we would have to send the unit back to the manufacturer, which in the UK would comfortably take upwards of 3 weeks. In fact, with one of our manufacturers, we would have to send the units to America for calibration, which caused us some long delays. This isn't a big problem with a large stock of equipment, but when you consider that stock, this time away from site is considerable. Take our 40 plus Zephyrs, for example. If we were to lose one of them every 2 years for 3 weeks, that's 120 weeks of earning potential for us, over 2 years of potential lost income for a unit. Now with the Zephyr, we simply order a new calibrated cartridge. We can keep the monitor on site and basically perform a hot swap. This constitutes a big win for us. We can then throw up a ladder, switch out a cartridge, be gone in 10 minutes. So, in conclusion then, KP Monitoring has now been using the Zephyr for over a year to supplement our EnView noise, vibration and structural movement monitoring with a robust air quality monitoring solution that's manageable, usable and reliable. The combination of the Zephyr with our EnView units means we can offer a complete environmental monitoring solution both for sale and as part of our managed monitoring services packages. We currently have all 40 plus of our stock Zephyr units out on sites across the country, with a large number of them situated throughout London. And together with EarthSense, we are building a more complete picture of demolition and construction patterns to help our clients control their dust emissions and create better living spaces for everyone. Thank you.
Thank you to our speakers. Thank you, David. Thanks, Richard. Very interesting presentation, interesting update. Hopefully the audience agrees. Now's the time for Q&A. So if anybody's got any questions they'd like to ask any of the presenters, please do put that into the chat. And we've got a few minutes now for Q&A at the end of the session. So any questions, please do feel free to ask.
I was going to say, we're not getting off that lightly, are we?
No.
Okay,
we do have a question here on cartridge calibration, probably a two-part question. Are the cartridges pre-calibrated? And what's the QC process once they're deployed? That's probably one for Dave.
Yeah, so I'll try and keep it sort of simple. Like we have a standardized approach on the OPC calibration. So we run a validation prior to deployment. So manufacturing line comes off, we run a reference instrument and we do a validation against that. So that isn't a calibration. Essentially, all the instruments perform the same on the network. And if it doesn't meet our validation and fit within our factory test, then it goes back to the drawing board and isn't included. The certification process means that that is then covered for 24 months. In terms of drift, we've had a lot of these running for a long period of time, and we've shown very minimal drift on long periods of time. But in terms of data quality control, MCERTS doesn't cover that other than the certifications. But to watch this space, there is in draft at the moment a standard specification to follow, which will show new methods to apply quality control for these types of instruments, and will be very relevant for public sector. It's called PAS 4023, and it plans to be published sort of middle to next year. So I'd say watch that space on that.
Thanks. So, got a question here on weather conditions. How do you find the monitors respond to weather conditions such as heat waves, but also in rainy weather as the inlet is not heated? Dave or Richard, probably.
Yeah, so that's a big thing with optical systems. Historically, they have a challenge because they would read moisture or water droplets as a particulate. There's two sorts of elements. One, we don't necessarily, well, we have algorithms in place to try and remove for that. So we're also measuring temperature and humidity, and then we're calibrate. Well, we're adjusting for that on the fly. We don't see massive problems in fog events, so we don't get very large readings, and we've shown that across the period. So we don't have a heated inlet. There is a small amount of heating within the cartridge. And the sample coming in has a small element which will take out very larger particulates. So as best we can say is we don't have the larger significant effects of water droplets. And the pushback, yeah, like we've got data examples to show this, and we've not seen massive effects on many of our co-locations, supplementary to what we've done in Teddington.
Thanks, Dave. And sort of a connected question to that, are there any recommendations for acceptable temperature and relative humidity ranges?
Yes, so we put those on our standard specification sheet. I won't reference those off the top of my head. We also do any instruments which are going to really hot climates. We can issue white shells, which will also help for places like the Middle East.
Follow-on question regarding the N certification program. Is there indicative NCERTS for NO2 or gas measurements? I think we've probably covered that one.
Yeah, but I can reframe. So like there isn't at the moment, but there is a certification. NPL are going through the testing to make sure that they can test against it, and in due course, MCERTS is going through the process of adapting the technical specification to MCERTS. So like I said earlier, watch this space. I expect that will be in place end of next year, beginning of 2024.
Thanks, Dave. Question for Emily or Richard here in terms of deployment. Is deployment normally done using a ladder, or is there a need to bring in a cherry picker? Has anyone got a ready-made risk assessment relating to deployment and links to ladder regs, etc.?
So typically, yes, we would install using a ladder. I don't think of the 40-odd monitors that we've got in the various locations we've had, then we've ever used a cherry picker to do it. And to say a ladder is a bit of a stretch. It's only 3 meters, so we may just use a step or a small platform for it. have we got a ready-made risk assessment? The risk assessment for our using ladders and so on is built into our overarching risk assessment that takes into account our noise and vibration and structural monitoring as well. So it's ready-made for us would be the answer to that. Yeah.
Thanks, Richard. Last question in the list here. Can you take a sample of the ambient particulate to be analysed in the lab to prove its source? It's probably one for Dave.
No, so I suppose this is referring to some of the other technology out there will draw the sample through an optical chamber and then through a filter which captures the particulates. We don't do that. So there isn't any filter which can be used to go onwards and do laboratory assessment for competition as such. But what I would potentially say is there's different methods of doing that. So those can be done probably at cheaper, lower cost alongside this if required.
Thanks, Dave. Further question here, we'll maybe just close on this one. In terms of upgrading and correcting 2022 PM 2.5 data, would you mind just re-summarising the process for that, Dave?
Yeah, of course. And for anyone who's a Zephyr user, please do reach out to us first. The reason for that is the certification covers an element of a serial number onwards. We just want to make sure that your instrument is covered within that before advising any of this. So that's the small sort of caveat. But what the correction on PM 2.5 means is you apply a slope correction. So you divide all data by a nominal figure. 1.257 is at the top of my head, but yeah, please do let us know. So it's something very simple. It would just be yeah, applying that slope. You could use a CSV, Excel or whatever. So yeah, if you're a current user, please reach out to us and we can talk you through the process. And like I say, our method is to decide a date for which we do start to apply it for all PM 2.5 data. We just want to make sure everyone is fully informed before that place, and we're not updating people's data without them knowing.
Thanks, Dave. Yeah, fair point. I think we've got time for one more. We will close on this one. There's a question, does the Zephyr come with a MET sensor, wind speed, direction, temperature? Dave, do you want to take that one?
Oh, I've got all the answers. Yeah, it does. So we the Zephyr has a port in its one of the cable connections. Currently, we support GIL weather stations, so anything on their MaxiMet range. So that covers a whole range of things. The standard thing which we will supply is a GMX 200, which covers wind speed and direction, but then they have ranges to add solar radiation, precipitation, and from a context of ours is the weather station simply plugs into our Zephyr. We supply a cable for it. A small caveat is it's a bit more power hungry, so then you wouldn't be able to run it on a solar panel. You need to use mains or power option. But yeah, the answer in simple terms, yes.
Thanks, Dave. I think we'll finish there, just about on time. Thanks again to all the speakers today. Hope everybody attending found the webinar useful and informative. Please do reach out. There's some details on the last slide there if you need any further information regarding any of the technology we've described, or if you've got any follow-up questions, please do reach out and we'll be sure to fit all those questions through to the team. Yeah, have a good afternoon. Hope that was useful for everybody, and talk to you all soon.
Thank you very much.
Thank you, everyone.